this video, we're going to look at dividing polynomials, and we're going to have two techniques for doing that. The first one is kind of a bummer. The second one is much easier. For the first one, we're going to use, these first couple, we're going to use long division. And when we have to use long division is when there is a coefficient on the divisor down here. So with this one, I could use what synthetic division that's coming up, because this is just a 1x to the negative 1x minus 5. With this one where it's a 2x, that is where the long division has to happen. And I'll go ahead and show that to you. It's pretty much what you would think of in terms of division. If you think of kind of old school long division, we used to go 3 goes into 14 4 times, and then we go 4 times 3 is 12. And then from there we would subtract, and we would bring down the next thing, and then we would repeat that. 3 goes into 21 7 times. 7 times 3 is 21, with a remainder 2, so I could write that as 47 2/3. So that little algorithm right there, 3 goes into this however many times, 4, this times this goes here, and subtract. That's exactly what we're going to do over here. It's just going to be with polynomials, which makes it a little bit harder. So x minus 5 is going to divide into 4x squared minus 22x plus 6. Okay, so instead of going x divides into this like we would with numbers, maybe an easier way of looking at that is, what do I multiply x by to make it exactly 4x squared? Because that's really what we're trying to do, is to multiply this by something so that when I subtract it cancels out. So I would have to multiply x by 4x to make it 4x squared exactly. And since it's 4x to the first, that means it goes over the other x to the first. And we have 4x times x. That's going to be 4x squared. And then 4x times negative 5 is going to be minus 20x. And then we subtract. The hard part is right there on those second terms. The 4 minus 4 is great. That cancels. That should happen every time. That's how we're picking what we're going to multiply by up here. The minus 22 minus the negative 20, it's kind of keeping track of all of those signs. So careful on this one. It's minus 22 plus 20 because it's minus a negative. So then that would make this negative 2x, and we'll bring down that 6. And then here, what do I multiply x by to make it exactly negative 2x? So that would be minus 2. Minus 2 times x, minus 2x. Minus 2 times minus 5 would make a plus 10 right there. And then we are subtracting. So this really did work. Negative 2 minus negative 2 would be negative 2 plus 2, and that does cancel, which is what we need to happen. 6 minus 10 would leave us a negative 4. And so if I wanted to write this answer out, I think in terms of the homework, you type this into the first box and this into the second box. If we were writing it on paper, it would look like 4x minus 2 minus 4 over that divisor, the same as I had the 2/3 for the example earlier. This next one is the same thing. It's just kind of one step bigger. So that's going to go 8x cubed minus 18x squared minus 7x plus 4. So what do I multiply 2x by to make it exactly 8x cubed? Would be 4x squared. And so the x squared goes over the x squared. 4x squared times 2x, so there's our 8x cubed again. 4x times negative 5 would be negative 20x squared. Those parentheses around there. That's gone. Minus 18, and that'd be plus 20, so that'd be a positive 2x squared. And then bring down the 7x. So now what do I multiply 2x by to make it 2x squared? I would just need plus x right there. So that times that gets me 2x squared. X times minus 5 is minus 5x. Again with the parentheses. Negative 7 minus a negative 5 would be negative 7 plus 5, so that's negative 2x, and bring down the 4. What do I multiply 2x by to make it negative 2x? That'd be a minus 1 right there. So minus 2x, minus minus, make that a plus 5. And then we're subtracting, so 4 minus 5, the remainder would be negative 1, so I could write this with minus 1 over 2x minus 5, if I was writing on paper. So that brings us to synthetic division, which is about 1,000,000 times easier than what we just did. It looks really confusing for a second, and then you're like, whoa, that's it. That was really easy. So let's see if we can get to that stage of it. With synthetic division, instead of dividing by the factor, we're going to divide by we're going to use the 0 of the factor. Part of what makes this really difficult up here is all this minus and minus type stuff, the subtracting with all the signs. So instead of using, this isn't a good example because it leads with a 2, which is why we had to use the long division. But here, instead of using x plus 3, we're going to divide by negative 3. We're going to divide by its 0. And we write it a little bit differently. And again, this looks like it's going to be hard for a second. And then it turns out to be super easy. And then instead of writing out all of that, we only write out the coefficients. So that has a little invisible 1 in front. So we'd have 1, 6, and 11. And then what we do with this is we always just bring down whatever's up front, because we're always going to be, it's the thing that always ends up 0. So we bring this down, and we go negative 3 times 1, and that makes negative 3. And then in this, we're saying 6 minus 3, but we could also think of it as 6 plus a negative 3. We basically do whatever math shows up right here. And so that's going to be a 3, and then we go negative 3 times 3 is negative 9. 11 minus 9, or 11 plus negative 9, is 2. And so you can see if I go, what do I multiply x by to make it x squared? It would be x. So this is always going to be 1 degree less than whatever I started with. So when I start with a cube, this first thing will be a square. When I start with a square, this first thing will be linear. So this is x plus 3, and then remainder 2. Or you can think of it as x plus 3 plus 2 over x plus 3. So to recap that, we use the 0 of the factor instead of the factor, so negative 3. We just take down our coefficients. This first one we bring down, because if we were doing long division, it would be like, what do I multiply x by to make it x squared? It would be x, and it's the 1x, so it's that 1 that's coming down. And then negative 3 times 1 made negative 3. Add those, get 3. Negative 3 times 3 makes negative 9. Add those and get 2. Same thing for this one, just slightly longer. So we're going to use a negative 2 because we have a factor of x plus 2. And we'll just copy down all of the coefficients. So 1, 10, 19, and 9. So bring down the 1. Negative 2 times 1 makes negative 2. 10 plus negative 2, or 10 minus 2, same thing, would be 8. Negative 2 times 8 makes negative 16. Combining those, we get 3. Negative 2 times 3 makes negative 6. 9 minus 6, or 9 plus negative 6, would be 3. And so this one started off as an x cubed. If I go x cubed divided by x, that would be x squared. So this first one is x squared plus 8x plus 3, and then remainder 3. So much easier than doing the long division when it's available. These last two, we can use synthetic because they lead with 1s in front of those x's. What makes these a little different is they are missing terms. They're not counting down x cubed, x squared, x, and a constant. This one's missing a couple terms, so let me show you how to deal with that. X minus 2, so I'm going to use a 2. It's my divisor. And then I have 1x cubed. I have negative 3 on the x squared. I have 0 x's, and my constant is also a 0. So I need those there as placeholders in order to finish out the division. So bring down the 1. 2 times 1 would be 2. Negative 3 plus 2 makes negative 1. And then just go again. 2 times negative 1 makes negative 2. 0 plus negative 2, or 0 minus 2 would be minus 2. And 2 times negative 2 makes negative 4. And 0 minus 4 would be negative 4. So this one would be, so you can kind of see I got terms for the linear and the constant even though I didn't have those factors up here, or those terms up here. So this is going to be x squared minus x minus 2 and remainder negative 4. If we were doing this as a long division, which I wouldn't recommend, but if we had to, we would set this up x minus 2 x cubed minus 3x squared, and then we'd have plus 0x plus 0. And then as I proceed through that algorithm, I would keep picking up, I would get a linear term here that I'd have something to subtract from, and I would get a constant as I proceeded through the problems. Again, synthetic is much easier if it's available, so we'll go ahead and do that. And for this last one, we're missing the squared term, so this would be 1, 0, minus 7, and 2. So bring down the 1, negative 3 times 1 is negative 3, 0 plus negative 3 is negative 3. Negative 3 times negative 3 would be 9. Negative 7 plus 9 would be 2. Negative 3 times 2 makes negative 6. 2 plus negative 6 would be negative 4. So it should be x squared minus 3x plus 2 and remainder negative 4.